A few weeks ago we restored this massive IBM retro battle station. And in this video we are going to try out a new method to repair Dallas real-time clock chips. We're also going to repair a RAM expansion card, fix the large gaping hole in the front panel, improve the cooling and upgrade the SCSI controller. If you want to watch the restoration too, I'll put a link at the end of this video. Okay, let's start with the most annoying issue with this machine. That is of course this large gaping hole in the front panel. Back in the day you could buy a nice cover to fill up this hole here. I have tried to find one of those, but no luck so far. Okay, this is what I came up with. I went to the hardware store and bought these plastic strips. And then I used a cutting wheel in the Dremel and cut some pieces to size. Hopefully we can make this work. It's a bit of a puzzle, but I think this could solve our problem. Now the tricky bit here is to keep them aligned while I glue them together. So I'm going to put some tape and tape them together to prevent them from moving. And then I'm going to turn them around and apply a tiny amount of glue in the crack here and then let it dry. Let's see if this works. Okay, I just got extremely lucky here. So while the glue dries, let's have a look at the RAM expansion card. I just got an email from Major Tom at Ardent. He had remembered that I had some trouble with this card. I know someone else is having the same issue. So he sent me an email and told me that apparently these cards are hiding away a Dallas chip. So the problem we're having with this card is that it works perfectly, but if I do a cold boot, then I get a black screen on the machine. And it won't work until I have removed this card. Yeah, check this out. I've got another chip underneath that SRAM. And yes, of course, this is a Dallas DS1213 from 1993. Okay, so we definitely have a suspect here. Well, I have never replaced one of these, so I'm not sure how to replace it. It kind of looks like it's just one socket stuck into another socket, but I don't want to just pull it off in case it's soldered. Let's instead desolder this chip and have a look underneath. I'll add some fresh solder to make it quicker and easier to remove. Two of the pins are bent, so I'm gonna straighten them up before we desolder them. My new nozzles for the desoldering gun have still not arrived from China, so I'm still stuck with this huge nozzle, but it will have to do for this project too. I'm gonna push gently on all the pins and make sure they're all free before we pull that contraption off. Yep. Okay, let's see what we will find underneath here. Oh no, this socket is filled with resin. I don't know if you can see it. I can actually see two round things in that resin. I hope the camera picks this up. But it actually looks like this chip has two batteries inside. Well, I've got plenty of replacements for the usual Dallas 1287. But this guy here is a special, so that won't work here. However, thanks to YouTuber Necroware, we know that the resin here gets very brittle when hot. So let's do some hardware hacking and see what we can do. Let's practice on this guy here first, since I only have one of these. So let's heat up this resin here. And I'm gonna start with the lowest temperature my rework station can do. That is 100 degrees Celsius. So the plastic shell here will melt if it gets hot enough. However, the resin inside doesn't melt from heat. Instead it gets brittle. I obviously don't know for how long I need to heat this thing up, but that's what practice is for. Now that's barely hot, so I'm gonna crank up the temperature. Let's try 200. I'm obviously skipping ahead here, not to bore you guys to death. Okay, so then it's about 30 seconds of heat and the chip is barely hot. It just cools down immediately. Let's crank it up to 300 and try again. Okay, let's try again. Yeah, now the plastic case has gone soft. We can start peeling it off. It's a bit tricky with just two hands. Yeah, 300 seems to be good temperature. Okay, so I'll go all the way around and peel that plastic case off and skip ahead here. Okay, I got that shell off on all four sides, but the resin cools down very quickly. So this is a bit tricky to get on camera because I have to reapply heat. But I think it's coming off now. Yep. Okay, the case is off. Now the resin is exposed. So they basically take an empty shell, fill it up with resin, and then place that chip on top of the resin. That's how these guys are made. To make this a little bit easier, I'm going to install a socket on an old breadboard, and then install the chip in the socket. Now it's going to be a lot easier to hold. I'm not burning my fingers. So apparently this stuff here doesn't melt. I would never have guessed. I'll keep the temperature at 300 C and I'll heat the resin up for about 30 seconds before we do the first attempt. Okay, let's see what happens. Well, it has gone soft and it chips away. Yeah, this is awesome. Look at this stuff. Instead of melting, it gets all brittle. This stuff is strange. Yeah, this is totally working. Oh, we've got some bent pins here to worry about. To attach the battery and the crystal, some of the pins are bent upwards like this. So I need to be a bit more careful. Yeah, not using much force at all. Just gently pushing that screwdriver into the resin. And it chips off. And here's our crystal. Awesome. Yeah, two more pins bent up here to mount the crystal. Yeah, and here's our battery. The only difficult thing here is to hold the breadboard and the rework station with one hand. Otherwise, this is easy. Really easy. Oh, something is coming out of that battery. It doesn't like the heat. Obviously. Maybe it's hot enough, so maybe I can skip the rework station for a little bit. It's a little bit smelly, but not too bad. I've definitely had worse. How cool is this? With all the trouble we have had with these Dallas batteries for years. And apparently it was this easy to fix all along. And I know there are other ways to fix this. But this is much more elegant. By replacing that battery, we can just reuse this chip. So now we only have a tiny bit of resin between the chip legs. Yeah, that's pretty much a clean chip. Let's pull it off that socket and remove what's left between the chip legs. Well, you get the picture. I'll remove the remaining stuff off camera. Okay, I got all the resin off. Aside from a few scratches that I made with a screwdriver, the chip looks pretty much brand new. So this was quite a discovery. Thanks Necroware, if you're watching this. Okay, let's see if we can get that battery off that chip. So as you can see, they have just bent two of the pins up and then solder the battery to those two pins. And I'm going to wiggle as I desolder these pins, because there is no PCB to scratch up here. And it tends to free up the pin. Okay, so this pin is free now. But how about this pin here? No, it's still stuck. So let's add some fresh solder and have another go. Let's try again. Yep, now it's free. But the battery is still stuck. Oh, awesome. So this chip here just says Dallas 1285, manufactured in week 11, 1990. So the battery wasn't glued in place, it was just stuck in resin. Okay, I cleaned that chip up, and except for a few scratches I did with a screwdriver, that chip looks pretty clean and perfectly reusable. So the only thing I need to do is to add a battery holder on top of it, and then I can reuse this chip in one of my machines. But that's not what we need today. That was just for practice. Now let's get back to our PS2. This Dallas chip here. This is definitely going to be a bit more tricky, since I want to avoid damaging that socket. I could probably replace it, but I'm not sure exactly how it's made. So I'm going to be careful and see if I can remove that resin without damaging the two sockets. Okay, so first I'm going to install some pin headers on top of the sockets. That way I can install it on the breadboard. And this should make it a bit easier. And the tricky bit here is going to be to heat up the resin without damaging the sockets, because I don't know yet if I can replace it. Probably can, but let's play it safe, or at least try. So I have lowered the temperature to 200 degrees Celsius, and I'll heat the resin up for about 30 seconds, trying to avoid the edges. Okay, 30 seconds later. Let's see if this was enough. I think it might be. Yeah, the resin is quite soft, but not near the edges where I didn't heat. And here's our battery. Now, how about the other side? Resin has gone cold. Now it's impossible to remove. So let's do 30 more seconds at 200 degrees. Okay, let's try again. Yep, oh, it's coming off again. And for sure, we do have two batteries in here. This module is a bit trickier than regular Dallas battery, but it's definitely working. But only briefly now that we have lowered the temperature to 200 degrees. So I'll crank it up to 300 again. Okay, 30 more seconds. Yeah, 300 degrees makes this much easier. So that seems to be the ideal temperature. Yeah, removing the resin on this chip is way more time consuming. By the way, I did a quick search online, but I can only find chips with old dates. But I'll just repeat this process off camera and skip ahead here a bit. And apparently the battery didn't like that much heat. So something is coming out from that battery, and it doesn't smell nice. So I'm gonna turn my exhaust fan on while I finish this off. Okay, so this is definitely not two regular sockets stacked on top of each other. The pins of this socket here are very, very long. They're just coming through to this side. And this is just a plastic shell. So I'll be as careful as possible not to damage it, because it could be tricky to replace. And here we can get a better view. So those pins are coming through the PCB and then through the resin. And finally the tip is soldered to the PCB. I decided to change tactics. So now I'm heating up a small area for about 30 seconds and remove that resin before I move on and heat and remove a small area again. Because this resin here cools down very, very quickly. Very strange material. As soon as it reaches below a certain temperature, it becomes rock solid and impossible to remove. But as long as it's hot, it's extremely fragile. And the most difficult part of this is to hold the chip, because it gets so hot. I guess I could wear gloves. Okay, I got all that gunk off and I scratched up the PCB quite badly, but I think I'll be forgiven. That stuff was pretty tricky to get off that PCB. But the important thing is that all the traces are still intact. And apparently I forgot to turn the camera on while I was removing the batteries. But as you can imagine, I just desoldered the two pins on each battery and removed them. This is what we're dealing with. So this large pad here is the plus for this battery here. The small pad here is the minus. And same thing here. This large pad is the plus for the second battery. And this small pad here is for the minus. So first I thought they were probably either connected in series or in parallel. But then I read the data sheet. And it's actually not that simple. And here's what it says. During the battery backup time, the battery with the highest voltage is selected for use. If one battery fails, the other will automatically take over. They seem to be individually connected to that Dallas chip. So we need to replace them with 2 batteries. And not just one, as I was hoping. Okay, so I'm obviously not going to install the batteries inside the module, in case someone needs to replace them in the future. So to make this work, we're going to need to solder short wires to 4 of these pads, and then feed them through the frame here. So I'm going to grab my Dremel and make some holes for those wires to come out. Okay, so I soldered wires to all 4 pads, and I drilled some holes through the housing to let the wires come out, and they should now sit flush to the card once this contraption is installed. Before we reinstall the module, I just want to document how that battery is connected to the chip, in case someone wants to hack it differently than I have done. Pin 2 on the chip is connected to this battery here, and pin 7 is connected to this battery. And these 2 pads here, they are connected to ground on this pin here. And the next step is to reinstall the module. Now this is going to be a bit difficult actually, so I'm basically just going to use the tweezers and try to align every single pin to the corresponding hole. So this is going to be a bit tricky to get on camera, so I'm gonna have to do this off camera unfortunately. Okay, that wasn't as hard as I thought. So next I'm going to solder 2 of the pins roughly in the middle. And here you can see that these wires here are pretty much flush to the board. I don't have any of these BR1225s, but I have a couple of these CR1220s. So I installed 2 of these in battery holders. These battery holders have small plastic tabs underneath. So I'm going to cut them off. This way they will sit flush on the card. And then I'm going to glue them down on top of the card, right above the module, just using some regular hot glue. And I switch to a really small tip. And I'm going to add a blob of solder on the tip. And now we can go ahead and cut these wires to size. I stripped the 2 wires. Now let's add some flux. A big splash of solder on the tip, because I'm gonna have to use my other hand to hold the wire down with a screwdriver. Okay, both wires soldered to the battery holders. Before we continue, let's check those short wires. Yeah, this one is good. And this one too. This module is designed to take 2 different SRAM chips. As you can see, it will take a slightly larger chip here. With the chip installed, it's a bit easier to check the ground connection on both batteries. So we can now install them. And if ever needed, it's much easier to replace them. These original BR1225s are at least supposed to last for about 10 years. The CR1220s that I have installed are not going to last quite as long, but I'm sure long enough for me. Now they are easy to replace, so it doesn't really matter. Now that we have checked and everything seems okay, we can go ahead and solder the remaining pins, making sure not to use too much heat, because a few of these pins are very short and can come off at the other end. I checked some more online, by the way, and I don't think these modules are made anymore, so this might be your only option if you have one of these cards. But if this works, it's totally worth it, because RAM expansion cards for the MCA bus is getting harder and harder to find. Okay, I cleaned up the flux, and my large nozzle made some ugly dents in the PCB. So that damn nozzle is worn out too now, and has some sharp edges. That new shipment of nozzles better arrive soon. Okay, I installed 2 4 meg modules, And this card is now ready to test. Looks pretty good, but the question is, will this contraption work? The glue has dried on the new front cover now, and it turned out okay. But these bits and pieces of white plastic don't look anything like the rest of the front cover. So I'm going to use some filler and see if I can make it look like one piece instead of strips glued together like so. Oh man, that is overexposed. Sorry about that, that got really overexposed. But I think this might work. I'm obviously going to sand this stuff nice and smooth when it has dried. While the filler dries, let's go ahead and install the RAM expansion card. Okay, everything hooked up. I'll start with the reference disk in the drive. Okay, let's flip that giant power switch and see what happens. It's counting up the RAM. And it stopped at 4 megs. We've got a 201 and a 165. I think the ADF files for that card are on this diskette. I guess we'll find out. You have installed or removed an adapter. Okay, so it recognized the card and it's now being configured and it's complete. It's counting up the RAM. Now it's counting past 4 megs. So those ADF files were indeed on that diskette. This RAM count takes a very long time. I have removed one of the cards on the motherboard. So we've got 4 megs on the motherboard and 8 megs on the card. So that is correct. We've got a very long error. Configuration error 162. Okay, I think it's complaining about that removed hard drive. Let's go to set configuration and view configuration. So we've got the XJ2 card, the Sound Blaster clone, and our Ecologic SimplyRAM 32 with 8 megs installed. Okay, so we didn't kill that card. That's a good start. And this is actually as far as we got the last time. However, when we did a cold boot, the whole machine just froze. We just had a black screen. Okay, now to the real tests. I'll turn the machine off and I'll disconnect power completely in about 20 seconds. So let's reconnect power and turn the machine on and see if we get a black screen. Come on, IBM. Yes! It's counting up the RAM. I think we fixed it. So before the repair, we just got a black screen after a cold boot. Now it seems to totally work. Next we're going to do an upgrade before we reinstall that hard drive, because this machine has a tribble card. And I found a Spock on eBay. It's marked with a question mark or a number 2. I can't really tell. So that is a bit worrisome. But I have washed the card and reinstalled all the EPROMs with some deoxate. So let's test it and see if it works. This card came without cache, so I have installed 2 modules. These guys are some kind of IBM specials, but I found some in my Model 30-286. However, they are gonna have to go back into that machine. So if this works, we're going to hack a set of standard SIMs to fit on this card in a future video. I don't know if this is necessary, but I'm going to boot the machine without the SCSI controller first, with the reference disk in the drive. And if I'm not mistaken, this is going to uninstall the tribble card. The PS2 has sort of a plug-and-play system. As long as you have the correct ADF files on the reference disk, it will install whatever card you plug into the machine. If you remove or install a new card, you will get a 165. That just means that it has noticed the change. Okay, reference disk loaded, and it just tells me that it has noticed the difference. So I'm gonna hit yes. I know it's automatically going to remove the tribble card. This may not be necessary, Perhaps we could have just installed a new card. But let's do it this way. Automatic configuration program complete. Now let's install the new SCSI card and find out if it works. I'll connect the hard drive and the CD-ROM drive. I'll fix the cable management later if this card works. I have downloaded the ADF files from Ardent and installed a copy on the reference disk. So let's put it in the drive and turn the machine on. Okay, fingers crossed. Let's find out if that card was marked with number 2 or a question mark. We have a 165 as expected, so it recognized the new card. Let's hit yes and do the automatic configuration. SCSI devices are being configured. This is looking good. Automatic configuration program complete. Okay, so it has recognized and installed the card and configured the hard drive and the CD-ROM drive. Now the machine boots. Fingers crossed. Let's see if I won the eBay lottery this time. So apparently this card here came from some museum. At least that's what the listing said. But it was untested. Back on the reference disk, I'm gonna set configuration. And then go down to set and view SCSI device configuration. This is looking good. So here's the controller with ID 7. And then we have the hard drive at ID 6. And then we have the CD-ROM drive down here. So this is looking good. Let's boot this machine without the reference disk. Yes! Starting MS-DOS. Machine boots. So that Spock is working. You never know on eBay. Sometimes you get broken old crap and sometimes you get a working card. Okay, the filler has dried. So I used some sandpaper and sanded that filler to make it nice and smooth. And then I applied a thick coat of primer and 2 layers of a creamy white paint. And here's the final result. And that actually turned out pretty good. That is not bad at all. So I'd call that a success. I decided to make a change to the hard drive installation. So I have replaced the diskette drive cradle and these rails here to regular adapters to take the hard drive from 3.5 inch to 5.25 inch. And then I use these printed rails that are copies of original IBM rails. I think this is a much nicer solution. The next step is to take care of the cooling in this machine. So this IBM predates all the standards. So the fan in the power supply actually sucks in air through the back and through this grill here and then blows it on the motherboard. So it's kind of backwards to what we're used to today. Unfortunately, this power supply was incredibly noisy, so I have lowered the voltage on the fan to 7 volts from around 10. That made this machine nice and quiet, but we need to compensate for that lower airflow. The only way out for the air is through this grill here on the front cover. So I tried to install a regular noctua fan here that would blow the air out. But unfortunately it wouldn't fit, because the side panel has this air duct here. So there isn't room enough inside the case. So next I went on Amazon and found this skinny fan. It's a 120mm fan, but this guy here is only 15mm thick. And that is exactly the space we have inside the front cover. So this fan will actually fit inside the front cover. Since the fan and the power supply is backwards, we're going to have to install this fan backwards too. This fan has rubber pads in all 4 corners, so it should get jammed and not move around once the front cover is reinstalled. I also made a custom cable for this fan with a small buck converter inside some heat shrink and lowered the voltage to 7 volts. So this machine should now be nice and silent, but still have some decent airflow, although a bit backwards. I didn't bother making the back of the new cover or the edges look nice, since they're not going to be visible. Well, it fits perfectly, and with the fan jammed in here, let's put that front panel back on. Hey, that looks pretty good. The random beige color isn't a perfect match, but it's not too far off from the original color. That's not bad at all. And it looks way better than that large gaping hole. Yeah, this actually turned out better than I expected. And that is a snug fit. There's barely any gap around it. Well, I thought this would be the last video about this machine. But the list of things to do is actually still long. When the next video is done, I'll put a link on the screen to that video shortly. If you're watching this fresh, hit the bell icon below and set it to all. Meanwhile, check out the restoration video of this epic IBM. I will end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you're a regular viewer, consider subscribing to this channel. Thank you for watching. I'll see you next week.